Good morning, everyone. My name is Eli Ben David, and I'm excited to present today to guide you through the software development lifecycle, or as it's commonly known as, the SDLC. As future software engineers, understanding the SDLC is crucial because it outlines the processes we use to create effective and high-quality software that meets or exceeds users' expectations. I will begin this presentation by establishing the importance of SDLC in delivering successful software projects. Next, we will look at an overview of the stages involved in SDLC and how each stage contributes to the life cycle of a software product. Finally, we will have a brief look at different SDLC models and their applications in various scenarios. The National Institute of Standards and Technology defines SDLC as a formal or informal methodology for designing, creating, and maintaining software, including code built into hardware. So the stages of SDLC are seen in this picture. So first we have analysis stage, next design, implementation, testing, deployment, and finally maintenance, which is by far the longest stage in the SDLC. The first stage of the SDLC is the requirements analysis phase. The goal here is to understand and document exactly what is needed from the software. We first begin by speaking with the stakeholders during requirement gathering sessions. These can be interviews, surveys, or workshops, and they're crucial for capturing both the functional and non-functional needs of the software. Once this information has been gathered, we conduct a feasibility study. The feasibility study helps us determine whether the project is actually achievable, and it considers factors like time, budget, and technology. And finally, the endpoint of this stage is the software requirements specification, or the SRS. And the SRS is a blueprint, and this blueprint has to be agreed upon by all parties. It's a reference point for the entire project. It's very important for errors to be checked here because one error can have a cascading effect down the line. For stage 2, this is where we transform the requirements that we've gathered into a detailed design plan. During this phase, focus shifts to creating the architecture of the software. We determine the overall structure, we select the right design patterns, and outline how different components will interact with each other. The user design interface is more of the front end of things in terms of design, and it's very important. We have to sketch out the user's journey. We have to ensure that the final product is not just functional, but also intuitive and user-friendly. We also make decisions regarding the platforms, languages, and tools that will be used to bring this project to life. Finally, prototyping. Prototyping is like a draft of the final product. This allows stakeholders to interact with the design and provide feedback before full-scale development can begin. The implementation stage is where our design documents are transformed into the actual software. Developers code the functionality that was outlined in the previous stages. We must ensure that we comply to the coding standards. This ensures that our software is robust and maintainable. We need to use practices like version control and coding conventions to keep our code bases clean and comprehensible. As features are completed, we continually integrate and test them. We do this to catch bugs early and verify that the implementation aligns with the design. Each piece of code is subjected to rigorous unit tests to catch issues early. The outcome for this stage is to ensure that the functional software is ready for comprehensive testing. Testing is where we ensure that the software does exactly what it's supposed to do and does it well. Testing is a long and rigorous process. We start with test cases that are based directly on the requirements that we had gathered initially. These cases are designed to cover all possible scenarios. Testing isn't one-dimensional. We perform unit testing to catch individual bugs, integration testing to ensure that different parts work together seamlessly, system testing to validate our complete application, and user acceptance testing to confirm that the software meets the client's needs and expectations. Testing is not just about finding faults. It is also an opportunity to gauge the software's performance, usability, and overall quality. When issues arise, we log them, track them, and resolve them. The end goal of this stage is a product that is not only functional, but also reliable and user-friendly. It is about delivering software that lives up to the promise of our design. Now that we have tested and polished our software, we come to the deployment phase. Deployment is a strategic and methodical process. We often start with a deployment plan that outlines the steps to move our software from a development environment to a production environment. Now, we can select our rollout strategy. We can choose a phased deployment or to deploy it all at once. This decision depends on the risk that we can tolerate. It's also the time when we ensure that not just the software, but also the users are ready. We must ensure that users know how to use the software. This means providing training, support, and comprehensive documentation. Once the software is live, we monitor its performance closely, looking for any issues that didn't show up during testing. We must be ready to respond quickly. Deployment is not just about delivering software, it's about ensuring a smooth transition and readiness for both the software and its users. Maintenance is the largest stage of the SDLC. It lasts for the entirety of the software's lifespan. Maintenance is about adapting and growing with the user. It involves the correction of any issues that come up after deployment and the implementation of changes that the users might need as their businesses evolve or as new technologies emerge. This phase includes activities such as updating the software to add new features or enhance existing ones, fixing bugs that were not discovered during the initial testing phase, and ensuring that the software continues to operate smoothly as underlying systems are updated or replaced. We also focus on optimizing performance as we gain insights into how the software is being used in the real world. User feedback drives further refinement, ensuring that the software continues to serve its purpose effectively. In the long run, maintenance helps in keeping the software secure and compliant with any new regulation. The software development lifecycle is crucial for structuring our approach to creating software, but there isn't a one-size-fits-all process. Different projects might require different SDLC models. Let's explore a few of these models. First, we have the waterfall model. This takes a linear approach where each stage must be completed before the next begins. The downside of this model is that it is not very flexible. Next, we have Agile. Agile is great for projects that expect frequent requirement change. It is iterative and allows for constant feedback and incremental development. The spiral model focuses on early identification and reduction of risks. It combines elements of both iterative and waterfall models. The V model is very similar to the waterfall model, but has a stronger emphasis on testing. And finally, we have DevOps. DevOps establishes a set of practices that automates the processes between software development and IT teams, enabling them to build, test, and release software faster and more reliably. Each of these models has its strengths and weaknesses, and the choice of which to use depends on the project's requirements, client needs, team size, and many other factors. Understanding these models allows us to choose the most appropriate one for our project, ensuring better outcomes and a more efficient development process. In this presentation, we went over each of the stages outlined in the SDLC. We have established the core purpose of each phase and highlighted their importance. In addition, we looked over different SDLC models, explaining what they do and some cases where you might choose to use them. I wanted to finish this presentation by emphasizing just how important SDLC is in software engineering. It is the backbone of projects, and it is incredibly important to become familiar with its stages. I would like to thank you for your time and your attention. Have a great day.